Hi, welcome to Batticaloa Model Railway. I'm Darshan. I hope every one of you are safe. Today we will have a quick look at how to connect the Cobalt Digital point motor or the Cobalt IP Digital point motor onto your control panel. So what I have done is I have experimented some of the articles that were available on the internet. I'm using actually a breadboard to do the connections and for the demonstration purpose, but I'm not going to show how it's connected to the control panel because that has been done in a previous video, and there should be a link up here for if you're interested in having a look. This is actually the control panel that I have done a previous video of. So here today I will just go through the circuit I have put together from the documents that I found on the internet. So let's jump into the video and see how I have connected the circuit. Let us look at this point motor connection. I am actually having a DCCconcept Cobalt Digital motor. This is an old motor that I bought it in 2012 and I haven't used it at all, but for the last 1 year I have been installing it. I had installed it, but now I'm in the process of doing a control panel. The previous video, if you would have seen, I have done another control panel using the 88FX DCCconcept accessory decoder. That was quite straightforward because you have different wires coming for the LED and signaling, which you can use it for the control panel as well. So with the digital point motors, you don't have to use any accessory decoder if you're using the DCC control system. I'm in the process of trying to connect my DCCconcept point motor, the digital point motor, to the control panel. So the new control panel is going to have two motors that have been operated by the 88FX. So that's going to be straightforward, as I have done all the other two control panels using that. For this, I'm trying to figure out how we can do the wiring so that we can have the LED lights on the control panel. So the connection is quite straightforward. So it's the black and the white is for the track, and the green, which is under here, is actually from the frog, for the frog connection. So this is the documentation I am following. There are other documentation. I have found another one which has been there for quite some time, but that didn't work out. The one that they have given for DCC concept digital motor, which didn't work. I don't know why. So this is another one that I have found out. I'll put the exact link so that you can you can find the documentation without any problem. So if you come down here, it has all the other previous point motors as well. So this is for the Cobalt IP Digital. There are 3 wires coming from the point motor, as you can see. So the 2 track power and 1 for the frog connection that is being used for the LED connections. So here we have connected a push button as well, because that's what we need in the control panel, so that we can use the push button to change the points. So the push buttons will go into 4 and 5. So that's what we have done here, and the way this is work is the 2 track powers come to the LED and the frog is connected to the common. So there are 2 resistance. You have to play with the resistance to get the correct brightness depending on your LED, and then there's a diode as well. So the only difference that I found here is for the LEDs that I have actually connected the anode, which is a plus, to the common. The other way it didn't work. So I'm not sure, but you can play around and see which one is actually working better or which one is actually working. So these are not bipolar LEDs, because if you are going to use bipolar, then you need to have the bipolar LED with common anode with 3 terminals. Only then you can get this working on this on your control panel. Otherwise the bipolar 2 terminal will not work. And here, if you can see, I'm just using this breadboard to do the circuit and the connection. So basically this is what I have done. So these are the two track power. The track power is actually coming from here, from my DCC NC control that I have here. So I have used these two red and blue one that's going into the power connection to the point motor, and the green that is coming from the point motor is going into the circuit as well. So you can see there are two resistance I have connected. One, I think this is 4.7 and this is 5.6 or something. So you can see there's a difference between the brightness. So this is the diode that I have, which is shown in the illustration. So these are the two leads that is powering the lights. So simply the main circuit that we have done here, I've done it in the breadboard because it's easier to change and play around with the resistance and to test the circuit. So as you will see now, if I press the button for the push button for the point motor, you will see the point motor working and the lights changing. So even though I have used two different resistance, there's no much of a difference. So it's quite straightforward. You can connect the same thing into the into your control panel. So based on which way the point motor is moving, the light will change. So accordingly you have to just place the LEDs where it will go, which route it's going to represent. What I have done now is I have connected more than one LED. This is actually a parallel connection that I have done. So on the documentation in DCCconcept, they say that you can actually connect up to six LEDs to your point motor. So I have connected around these 4. So when I change the point, you will see lights changing and all 4 are on now. So this is quite handy when you want to do a route that will represent once the point is changed. So this is quite good. Okay. So if you want to use more than one LED, or probably you will use more than one LED to represent the routes once it changes. So this can be connected as shown here, which is the same thing. So I have just taken these 2 wires and this is in parallel connection with this. So I just made the same connection from for this light. The same connection has been made for this as well. The other thing that I want to show you is what happens when we switch off the power and then we switch it on again. So okay, I will switch off the power now. So all the lights will go off. So everything goes off. So now let's switch it on again. Okay, as you can see, all the LEDs come back. It remembers the position. So it is quite handy, because with the 88FX we couldn't do this, because when you switch off and switch on, none of the lights come up. So you have to go and press the push button once just to see where the points are. So this is quite handy, because when you switch it on, it straight away lights up. This will light up the control panel. The other thing that I want to show you is the DCC my control. So if I select the accessory and I press one, that's on the same side, and you can see the point motor moving, and accordingly the lights will change. So it's worked out quite well. I've spent a lot of time to figure out this, only because I couldn't find this particular article in the first place. So I ended up trying and wasting some of my LEDs as well, but I'm glad everything has worked out. So I thought it's very good to put this video together, because I couldn't find anything on the internet, on YouTube. So hopefully this will help anyone who is looking for how to connect the digital point motor onto the control panel. Okay, let me explain this. Now I have done the control panel. You can see the lights that are on is actually coming from the Cobalt Digital and Cobalt IP digital meters, point motors. So as you can see, if I press once, it change. So what I have explained in the breadboard is the same connection that I have used here. Only difference is because of the LEDs are being quite bright, I have actually used 65K resistors to reduce the brightness, and it seems to be working. Hopefully it will be okay. Okay, as you can see that here I have two blue push buttons. These are actually the connections that are coming from the 88FX. So these are for the tortoise point motors that I have, the analog ones. So I have used a decoder, accessory decoder, but the issue was the connection to this to the points, from the points to the 88FX is around 7 meters. So when I actually connected it, the points didn't work properly. So what was happening, the points were actually making some random movements as soon as you connect the push button. So what I ended up doing is to put two push buttons instead of using one. I have used two push buttons. So if you see, if I press this, so that's the through line coming. These are the two continuously illuminating lights that I haven't actually given the connections yet. So this is to exchange. So that's the crossover. So you can see that one light coming up. But if I press that, it doesn't move back, because then you have to press this. So it's actually operated by two push buttons. Same here as well. So that's for the one, and that's for the second, and you can see the point motors moving. So if I can show you the wires that's coming through, so you can see, as I said, this is the control panel. The connection goes along here, and one motor is here, it's connected here, so that's probably around 2.5 meters. So one point motor is here, then the other one is here. You can see these are the 2 points that I've done for the 88FX. So one here is the other one. So the line comes around here. You can see the the green cable coming down, and it comes up to here. So this is the 88FX connection. So the panel above here is connected to the 88FX. All these points are fine because I can use with one push button, but only for this, maybe because of the distance. But on the forum they're saying that if you put a diode it will work. I tried once, but it didn't work, but I then ended up putting the two push button, which seems to have solved the problem. So I'm happy with it for the time being. I think I can live with it. Okay, I think that's about it for this video. Thank you very much for watching.